Hi everyone, today we have our second lesson, Machine Learning Engineer. So the lesson is hosted by our school, Black Screen AI, and programming school Black Screen AI was founded in California in 2016, and it's more than 8 years. 8 years. We work with students from USA and Canada, and also we have more than 3,000 graduates. Here you see photos of our students from different seminars that we had offline in USA. Also, in December, we will have our IT workshop in Miami. So if there is anybody from Miami, you can sign up for this workshop and visit us. Um, Also, if you can't join us offline, join us online on YouTube. We have our YouTube channel where you can find different videos and recorded lessons. Also, there you can find interviews of our graduates where they speak about their experience of starting IT from scratch and then getting their first job offer. Here you can see companies where our students, like from which our students got their job offer. So here you can see Google, Meta, Walt Disney, which is really interesting. And about machine learning, so everyone knows that now AI and ChatGPT, for example, became really popular, and everyone now, like most people, use the AI in their everyday life. So we just wanted to say that the market will grow, okay, and right now is the best moment to start studying machine learning engineer, to become machine learning engineer. Um, like 76% of companies trying to use AI in their projects, and machine learning engineers are really required. So after the course, it's like 80% that you will get your first job offer in 3-4 months. And today we have our mentor. His name is Maxim. So he will be our second teacher on our machine learning engineer course. So Maxim, you're welcome. Take the floor, please, and speak about yourself.
Thank you very much. Let me share my screen. Could you please give me permission?
Done.
Okay, so can you see the slides?
Yep.
Okay, perfect. Thank you. So my name is Maxim. I have more than 5 years of machine learning experience and research and commercial in different companies in Europe, US, and Canada. And today let's discuss real-world applications and future trends of the AI and machine learning. So let's start from the AI progress in the past, but not actually the past, maybe the recent times. So first, let's understand why we need to use the machine learning. So machine learning not the best choice for any task. It could work well with the problems that we don't know the exact algorithm or solution, or the solution is very heavy. For example, the first task of the ML is classification, and if we need to distinguish between cats and dogs, uh, we don't know the exact algorithm that could process every pixel and tell us if this is the cat or this is a dog. So machine learning is the good application in this case. And also we can look at the chess game. So this is very complex game. It requires a lot of movements prediction, and the algorithm could calculate all the movements, but it will take very, very long time. So the machine learning is a good task to cut the computational cost of the computation of this task. Uh, so let's just look at which tasks in general machine learning can do. So the classification, as I mentioned, when we need to classify like cat, dogs, horses, etc. Also, the very famous task is the regression, when we have some values for some function, we can say, and we want to predict what's going next. For example, we know how much the house cost like 2 years ago, last year, this year, and we won't predict what it's going to cost next year about the some set of parameters. Also, it's clustering. It's unsupervised when we don't have the labels. Like in previous example with the houses, we know the house type and price, but here we just, for example, know the houses, and we want to uh, make them in different clusters. For example, houses near the shore, like houses in the forest, something like that. The next task is recommendation. You probably can experience it in the YouTube or TikToks, social media, when the algorithm just recommend for you the most appropriate video. Also, it's synthesizing and sampling. It's just easy example ChatGPT that could gives you the any text, any answer to any question you put in, or the anomaly detection, where we need to spot any outliers in our data. For example, we will look at this later. For example, we want to know some fraud detection with the credit cards, and the unusual behavior with credit cards. It's the outliers, and we want to detect them to save the money and increase the safety. So, as you may know, neural networks made up with the layers, and each layer processes the input and gives the result to the next layer. And so they pass the information farther and farther, processing it. And the main thing here is that each layer itself is detecting and learning the features from the, for example, in this case, the image. Uh, if we want to classify the car, like to know what car is it, the model will distinguish the features, like it has, all cars has the wheels, and it could just understand, we can see some black circle here, like this feature. So it's probably will be a car, and with combination with the other feature, we can say for sure, yeah, this is a car, and we can say what model of car it is. This process of passing the information helps the network make sense of data step by step and solve the problems. Network, you can see here, it's called convolutional neural network. Convolution is the basic block, like the brick on which the whole model architecture is built. So let's dive a little bit in the history. So the first vision processing model called LeNet, it was made like more than 30 years ago. You can see the image, it's like the piece of the history here. The first model was designed to recognize the images on the bank checks, and you can see it do pretty well, even with the hardware of that time. Then the Alex ModelNet appeared. Like before that, the people trying to extract the features by hand or like semi-automatic way, but the AlexNet was the new architecture, revolutionizing architecture that could learn the feature as I showed you in previous slide. Then the neural networks just upgrade to the new models created. For example, here I listed the YOLO is very famous type of architecture called You Only Look Once. It's very fast and could be used for real-time problems where you need to find information very, very quickly. And the can say latest trend, it's visual transformers, and maybe all modern, as we know, open source vision models built on these visual transformers is very, very powerful architecture. I will talk about these big models a little bit later. So this is model more for the computer vision models, but also we have the task of natural language processing, and it also has its own history. So firstly, some uh, initial tries of understanding language appears in a recurrent neural network when they try to process the sequence like word by word. Next, the word embeddings appeared. I will talk about them on the next slide. Uh, then appeared sequence to sequence and transformers. This actually is the same architecture as the visual transformers because firstly transformers appeared in the natural language processing, and just the computer vision community just thought, okay, this worked very, very good for the text. How can we transfer it to the images? And they just, okay, we will split the image by the pixel patches and call it words and just pass it to the transformers. And surprisingly, it worked. And we have these very strong architectures now. After that, on the base of the transformers, start appearing different architectures like GPT, of the face of GPTs. This is actually, we can say, the father of the ChatGPT. This is a very, very big stack of the transformers, the previous model, and also the smart hacks of data extracting and learning. So as I promised, let's look at how embedding works. It's really, really interesting. For example, we have the word king, and embedding allows us to represent this word in the high dimensional vector space. So we can assume this king word is actually a vector. But what if from this vector we subtract the vector which represent the man? So we will have the main person in the country, but without the man part. And if we add the woman part, we will get the vector that represents queen. So it called the parallelogram rule when we can build this equation. Then another example, we can tell like if we take the country like Italy and remove its capital Rome and just add the capital of different country like Paris, and we will get in the result the France. And these embeddings understand the relation of the words, and we can do this mathematic with them. Okay, so let's look at the newer model, most complicated model that exists now and used very much. One of the trends today refer to multimodal generative AI, where we can generate any modality out of any other. So this include large language models such as GPT, Llama, Claude, etc. We just input some text and we get text to the output. Also, it could be some large vision model when we input text or image, and for output we can have another image or text. That's all our task. This can actually be the different model, like one that get text output text, another that inputs text and outputs image, or it even could be the one model that takes a lot of modalities and generate any other modalities. And how it works actually under the hood, the models learn from a very, very big amount of data. It's a large data set of text, images, audios, videos that are combined in a very smart way. And it generates a new context by predicting what comes next or creating a pattern that fit the data. Uh, Generative AI used now in all industries. It's chatbot, it's content creation, and many, many more. We'll talk about it a little bit later. So one example I want to show you is the Microsoft uh, AI simulation of voice. So the person could just record the 3-second sample of his or her voice, and the model, after processing it, can say anything with this exact voice. This is the example of audio to audio generation. And if we want, for example, to generate some image from the text, for example, we can specify we want cat astronaut of the Mars, and such models such as DALL-E, Stable Diffusion, or Flux can give us something like that. The models learns to associate these words with the visual elements from the dataset, and then generate the images by understanding the text and creating some visual representations. Moreover, we can even generate the video. The recent Sora model that was revealed like a few days ago allows from the any prompt to generate the very, very realistic video. You can see the example here. This is generate from text to video. And next, let's look at the large language models. So this is the very, very big tree of different language models you can see here. In the bottom, there is GPT that we discussed previously. And from them, there are a lot of newer model growth like GPT-4, which is very popular now. It takes the lead of the most of the task. It's a Claude, it's a Llama model, and many, many more. And despite these models are powerful, they can suffer from the bias and hallucinations. For example, the model could mistook the men and women's. For example, if we take the word doctor in the text on which the model trained on, mostly doctor refers to the man, but we do not specify is it man or woman, so the model just could wrongly assume it's a man. But so this type of bias, the researchers try to remove by improving the models, by improving the input data, but this is still a big problem now. And the next question arises that how we can compare to different models and say which one is better, which one is worse. There exist a lot of different metrics. I just provide two of them, but I think you will get the point. In the left one, you can see the multitask reasoning when we just ask him language model about some task and ask to explain, to reason its answer. Or we can just give this some piece of math, like solve this math equation, prove this theorem, and just look how the language model will behave in this case. So the recent OpenAI O1 model, it's taken a lead in both of these fields, but actually it's not the best in all tasks because some model could be trained for exact task to perform, so they can do better in one field but lose their like general abilities to make some multitask reasoning or math. If, for example, it's trained to produce the Python code, let's say. So let's get back to the visual models. However, large models could be very good for some tasks, but they not used like everywhere, we still may need use some convolution neural networks if we want to solve some narrow task. For example, if we want the real-time performance, as I said, we can use the YOLO architecture, for example. It is still good, but if we use the large vision model, we will require a lot of GPUs because it have a very big computational cost. And actually, I trained to run the large vision models called Lava on the controller, which has only one CPU without any GPU. And it took just more than 10 minutes to generate only one image. And obviously, in the tasks, like for example, traffic cams that make the uh, photo shoots of the cars and process their license plate, we need to read the license plate very, very fast. It's almost real time application. And in this case, if we have to wait 10 minutes, it's unreasonable, obviously. But it's good for multitask solution. And I want to show you one of my favorite models. It's called Florence 2. Despite it's very easy relatively, the dataset was constructed in a very smart way. So here's the example. We have the image for the input, and we can have some text that say what we want to get from this image. For example, we can just say what this image describes, and it returns us, I can see the uh, person on the bicycle, the car, the road, etc., etc. Or we can say locate the object on this image. And the model will just draw for us the bounding box, return us the coordinates where each object located, like the car or the person. Moreover, we can just say locate a woman riding a bike, and it will find only one object of the woman riding a bike with coordinates. Or we can just ask for the region, like what's going on in this region, or we can ask to just draw every pixel of the woman riding a bicycle, and you just return us the mask of this bicycle. Actually, this task of uh, assigning pixel to the object called segmentation, and another good model from the meta research called segment Anderson model. It's very good and used, I think, a lot of in nowadays. So we also have the image and process it into some encoder. And we have just the text that tell us what we want to segment. And it will return us the exact segmented object. So it returns us the pixel mask of this object. In this case, it's scissors. So it could be very useful when we need to get some object from the image and only it without any background. Actually, there are a lot of state-of-the-art computer vision tasks exist here. It's image classification, detection, segmentation, so on and so on. If you're interested, you can just look at the website I provided. It's very good. I use it a lot. So now let's try some example to run the large widget model. I think you remember this time where the Microsoft had a bug and like all airport stops working, and they just started to make the handwriting boarding passes like this one. And I had a problem to detect what's written in this boarding pass. Like the client wants from me to parse the text, the name, the flight number, and any other information. So let's look how we can do this. Let me share another screen. Can you see the code?
No. Right
Now,
now,
can you?
yes. Right now, yes.
Okay, perfect. So we can have some wrapper around the GPT model. I use GPT-4, and it just had the prompt that's saying, please extract all the information you can see on this image, like the name, last name, flight number, the cities where it's going to. And I just passed this text and the image to the program. Here I loaded the image example of this boarding pass. Let me uh, print it. Here we go, the same image. And let's try to run this getInfo function from this image, what it extracts. So it extracts the name, Akshay, which is correct. Last name, which is also relevant. The seat, the flight number. So that's how you can process any image. Just the small example, and a lot of businesses requires just to extract some information from the photo. It could be a website, for example, and you need to extract some information from the website, but you may not just parse it in a good way. So just providing an image could be a good thing, and ChatGPT or any other vision model could just process it and give you the result, and you will process it and build the pipeline from that. Okay, let's get back to the presentation.
Okay, we see the
Okay,
presentation.
okay, perfect. So let's look at the more concrete examples. For example, how we can use AI in healthcare. So AI algorithms can assist in interpreting the medical image, like you see the MRI and mammogram, for example, and they could aid in early detection of conditions like tumors or fractures. And here you can see the example. Or it could be a predictive analysis for patient outcomes. Like by analyzing patient data, AI can forecast the disease progression and treatment responses, enabling personalized care plans. And another application is the drug discovery. AI accelerates the identification of potential drug candidates by predicting molecular interactions and outcomes, and reducing development time and cost for this task. Also, it applied in finance. For example, it's a fraud detection. AI systems detect the suspicious transactions by identifying the patterns. Also, it used in algorithmic trading. AI executes trades based on real-time market data and predictive analysis, optimizing the investment strategies. Also, it's credit scoring. AI evaluates the credit worthiness by analyzing diverse data sources, improves the accuracy of lending decisions. And maybe the biggest field is AI for business. So I think nowadays every website has its own customer chatbot that can handle customers' queries, providing instant responses. It's sales forecasting, like market trends and historical data analysis to predict sales, or it could be marketing personalization. I remember the interesting task that I done recently that, for example, user load image of itself, like on the left, you can see here, and select some clothes like this dress, and the algorithm should like try this clothes on the user without changing its uh, body proportions, and to display how it looked like on the user. Yeah, it's very popular feature right now. Also, AI used in manufacturing, its quality control, AI-powered vision system inspect the products for defects and just alarm if something went wrong. It's supply chain optimization, of course, AI forecast demands and manage inventory levels. And this is robotic process automation. AI-driven robots perform some repetitive tasks, such as assembly and packaging, increasing efficiency and reducing human error. And of course, this is automotive. The autonomous driving system uses AI that allows vehicles to uh, perceive their environment and make driving decisions. Also, it's predictive maintenance. For example, AI analyze the car data and predict if some components has some failures and allowing timely maintenance. And also, it's driving monitoring. AI system can monitor the driver behavior to detect drowsiness or distraction and enhance safety by alerting drivers or taking corrective actions. So what's going to happen with the AI next? So probably uh, when we like humans become more proficient in quantum computers, I think we will mix it with the AI and can train our AI models much faster. Also, it's obviously AI impersonalization. The next thing it's robotics. Maybe you heard about recent Tesla robots, and they also run on the AI. And I think in a year or two, they will have the more mental model and understand the world and people better. Uh, Also, we will have more better models for like video generating because today's state of the art, they can generate not very long videos and they could have a lot of artifacts actually. So in the recent years, it could be removed. Also, a lot of personalization will await us. I guess special some discount options, some marketing options will be present for any user. Uh, in 5 years, maybe some as the CEOs of the big companies uh, promise us the global artificial intelligence can come out. So this is actually the artificial intelligence that could do any task compared to human, but much faster. Um, this will be the very revolutionizing technology, actually. Uh, Also, development in quantum computing can do this much possible for in a recent future. And in the 10 years, there probably uh, researchers will want to find some more lightweight models because to train large language models cost a lot actually and takes a lot of energy. So just improvements these parameters could be beneficial very much. And also, uh, you probably heard about Neuralink. So some brain interface could be possible with the collaboration with AI that could create maybe some half robot, half person mix. Probably this could happen in the 10 or more years. And we will see. Let's wait for this astonishing AI work. So thank you for your attention. If you have any questions, I'm ready to answer.
So I see question in chat. What kind of tasks is a chess game?
Actually, chess game is uh, kind of different task. I do not list all the tasks. It's just the major list of the tasks. Exist a lot of many others. Chess game is just the uh, it called itself the games or the uh, sorry, I forgot the word. It's some different kind of learning where you train the game play with itself, and it's just train uh, much by much to improve itself by uh, yeah, playing with itself.
Thank you. And the next question is, what kind of OS Tesla robots, for example, use? Are those real-time or multitasking?
I'm not sure about the uh, OS, you mean operational system. I'm not sure about that. They're pretty close, I guess. Uh,
Yes, correct. Operating, you've been mentioning that real time for the car driving, and then you started to talk about AI. So I'm not sure how to connect those two concepts. I mean, the driving apparently require RTOS, and then the AI is something else. So I just need you to explain.
uh, yeah, what I meant, like Tesla recently developed the robots. It's something different than the cars. It's like another product which can perform day-by-day tasks, and it has some visual models to analyze the environment, and it's kind of complicated models. But in the cars, they have the uh, embedded system, so they use mostly convolutional neural networks rather than big vision models because they need to make decisions very fast, and automotive is the place where you need to do the instant decisions. So they probably do not use the big models in the cars, but actually this is the close thing, and we just can guess what they do, but most probably they use the convolution neural networks.
Yeah, well, I guess for robots, it's going to be something like multitasking, that the one that do is concurrency parallel. So I cannot imagine that they're going to be as fast as those that we embedded ones, as you said.
So could you please repeat the question?
I just wanted to know that robots and AI uh, generative systems, how efficient they gonna be, as we use, for example, in a car driving embedded system, they are pretty quick, so that's how they're useful. But then generative AI, I'm not sure what kind of functioning are we gonna have with them and with those robots. So I just wanted you to assess this situation and make prediction on in regards to efficiency.
So probably for robots, they use uh, the calling of the agents. So this is the some small functions, and the global uh, model just call each function. It could just split the whole task into the subtask and call uh, in separate each function. So it's much more complicated than in driving. For example, in driving, you could detect the car and just take the action to turn left or right, but here you need to process like kind of things called chain of thoughts, maybe. When you just have the information, you process it, you analyze the environment and get uh, and get get another piece of information and process it as well. And this is the very, very long chain of predictions and calling the small agents inside the robot.
And well,
Yes, Maxim, please unmute yourself because I muted everyone right now.
Yeah, I'm
Yes.
not sure if I heard the last words I said.
No, please repeat.
So what I meant that Tesla robots could have some different chain of thoughts algorithms where they call different submodels to process some task, and they just get the, for example, vision or sound information continuously and just process it and know what next function to call. Maybe this how they work, but I don't know exactly. I can only guess.
Okay, there is one more question. No, it's not question, it's just opinion that Tesla cars autopilot is very early state, need 10 years to development. Okay, thank you.
Yeah, I can say a couple words of that.
Okay, comment please.
Yes, indeed, the like general autopilot is not ready yet. Maybe they could perform well in San Francisco somewhere where the locations is well known. And actually, I know the Silicon Valley companies that train a lot their solutions on the roads, San Francisco, and maybe they just memorize what actions they should take there. But yes, in the very general conditions, maybe in the bad road, bad weather, it's not the perfect autopilot. And as you may know, the Tesla still requires to not distract and look at the road, hold the steering wheel, and just to be cautious not to distract yourself.
Okay, thank you. Are there any questions? Yeah, if not, I will move towards our slides. And if you will remember any questions, if any questions come to your mind, don't hesitate to ask us, okay? Great. So how we can become an machine learning engineer. So first of all, I guess it's if you have any experience in IT, for example, as developer, QA tester, so you can move to machine learning engineer. Also, if you have like any degree in computer science or something similar, you can also go and study machine learning engineer. Gender and age do not matter, of course, because on the interview they um, pay attention on your technical knowledges. If you have any experience as machine learning engineer, and also they pay attention on your soft skills, how positive you are, how like open-minded, and like something like this. They don't look if you're like man or woman, how old are you, all these details doesn't matter. And machine learning engineer is profession for those who work in team, because it's important to like machine learning like they make brainstorming and all this stuff. So it will be nice if you will mention that you're a team player. Here's our motivation for junior, middle, and senior specialists. And you consider to be junior if you're up to 12 months, then you go to middle. And how you can, like for junior, it's a little bit more difficult to get your first job offer. So our course give you internship that you after when you go to the market you will mention this internship like your experience, because it will be a real project and you can put up to 12 months on your CV, and you will pass background check. So our graduates will go to the market as middle specialists. If you if you start studying machine learning engineer from scratch, so then you go to internship, but I suggest you to try to go to the market as a junior specialist, like, and then, or something like working uh, for some other internship just to get more experience, and then put your experience in your CV and become middle specialist. So you understand that for for junior and middle specialists, they're like there is a big chance to get job offer, even like with the experience after the internship. So here is a screenshot from Indeed, and you also can look on LinkedIn what um, salary, what base salary average is in your state, for example. Here is the program of the course. What we will learn during our 6 month course, what tools we will use, and if there are any questions according to the program, you can also ask in our Zoom chat. Yes, so you can claim a middle class upon middle position after graduation, as I mentioned. Yes. What's included in our course is that it's 6 months machine learning engineer course. If you don't Python, it's plus 2 months studying Python. And after that, you go to internship where you work in our team. Okay. It's a real project, and you will work with team of developers, testers, DevOps engineers, and other machine learning engineers. You will connect AI to our CRM system, and then you also will work with our HR manager, which is super helpful, because when you go to the market, it's a little bit scared because you don't know what they ask and what answers you should give. So our HR manager will prepare you for behavior interview, and also you will write together your CV. Uh, the the CV and LinkedIn profile are really important, because it's like first impression that you give to HR manager, to recruiter, and it depends on your CV if you will have your first interview. So if your resume, if your CV, if there is something wrong with it, so you won't go to first step of the interview process, which is really bad. So yes, we will help you um, to build your CV, your LinkedIn profile. You will be prepared for behavioral interview, and the most important, you will have experience in your CV in American project. Okay. And also all our classes on the course, we have there are 3 times per week, and all classes are online in Zoom, so you can ask questions, and then we record each lesson, and then you can watch the recording. And also we have Slack, and there is group chat, so you can ask questions there. Here is timeline. As I said, we start February our course, but you can book your place right now. You can book it for now, like now, and then study to prepare. For example, you can start Python right now. Um, yes, you can start Python December, January, and then on February you will be ready to start machine learning classes, which is really nice. Yes, opportunity. And at summer you will be ready to go to the market, to go to the internship, and October, November you will be ready to go to the market. I guess that's the timeline if you will start now. About internship, you can participate there um, like as much as you need, and when you will feel yourself comfortable, you will go to the market. But at least you should participate in internship for 4 months. 4 months is minimal required. Okay. Um, then so you will have career coaching and go to the market for your first job offer. Um, like our training program, you can also see our training program on our website. There, like you can find their courses, machine learning, and then there is training program and also the price and details. So here is also our topics, which includes in our program. So I have Zoom. I have questions in the chat. Is everyone for sure going to get an internship placement, or is getting into the internship also some sort of selection process? No, no, no. It's not selection process. Every student that passed the course, after the course goes to internship. Price in the end, you will have special offer. And are there any math prerequisites, maybe linear algebra required for this course? So it will be really, really nice if you have any knowledges in linear algebra, if you have any degree in maths, or it will be really, really nice if you have any IT experience in, for example, as a full stack or front end developer. Otherwise, it will be really hard for you to start machine learning from scratch. So, okay, so I guess my answer is yes. You should have background. Question from Stan, and that's the question for Maxim. Maxim, please. For a developer output, is a code program feature for QA pass test or not automated test for DevOps infrastructure? What is an output for an ML engineer?
I don't get exactly what you consider the output. You meant like the uh, what developer do and what ML engineer do, like in their work. If so, then the work of ML engineer is the close to what developer do. It's just solve some problem and produce the code, the program, but it just the ML engineer utilize the ML models like build, or ML engineer could build from scratch or to retrain the existing models depending on the task. So this is still the program, still the code, but it's just slightly different than the regular code. Like in the website, for example, you build just the different task you're solving.
Okay, thank you. And moving on, there was question about the price. So here it is. Your special offer for participants. We had it yesterday and we have it today. You see, it's like you see here is a QR code which you should scan, and our manager will contact you and answer your questions. And then if you are ready, we will send you invoice to pay and to book, yes, the course for you. As I said, you can also start with Python now, and then in February move to machine learning models. Also, please scan QR code if you choose this variant. So our manager will call you back and you will tell that you need Python course. And like, if there are any questions, also you will ask, and our manager will give you consultation. Okay. Another question for Maxim. Model is a branch of weights of network nodes.
Well, generally maybe yes and no. So indeed the weights is the main like core, like what parameters you have to process the input, but it's not enough to have the weights because weight just number. So you should have the architecture where you apply this ways, right? So you have the model architecture, you have the weights, its parameters, how it processes the input, and then how it works. So it's just not only the weights.
Okay, thank you. About the course, um, the you see here that the number of students in the group is limited, and that's true because machine learning engineer course is really difficult, and there's a lot of topics, tools, and so on. So there are like 6 places in the group only for 6 students. So that's why we start offering you to book before 2 months. Yes. So again, here is our QR code, and if you can't scan it, just make print screen. Okay. Are there any questions according the course, the program, the lessons, the internship, or interview preparation? Don't hesitate to ask us. And here is more like frequently questions that we are asking. It's about like when is the start? The start is on February 3rd, and the course is held for 6 months. Lessons are 3 times per week. The duration of the lesson is 1 or 1.5 hour, because that's a lot of information. And if we make it 2 hours, so you just don't get the information well. That's why we try to make 1 or 1.5. Also, we try to make our lessons more practical. So if we study theory, the next lesson we will do practice on this theory. Or also we try to explain theory on practical, showing you like the practice. And that's why a lot of students like us. Yes. If you are not able to attend the class, as I mentioned, we record every lesson, so you can rewatch the lesson in recording and then ask questions in our group chat. And what's included is job assistance. So yes, we have mentoring sessions, mock interviews, and resume building, which means that our HR manager will work with you in order to prepare you for the interview process. Yeah, there is question in Zoom chat. Do we start with main concept of ML and then we move on specific like data science, etc.? Okay, let's move to our data science is different profession. Absolutely. But yes, we start with concept of machine learning, and then we move to um, tools with which a machine learning engineer work. Yes, here is the training program. Yes. So you see that we um, we learn concept of machine learning, and then we move to classification and tree-based methods and like working with data and so on. Here's the program you can see. Okay, there is one more question. Past website had internal mail course in Russian and English. Russian course was supposed to be 8 months and English course 6 months. Could you please say the difference? Yes, the difference is about Python. The English course starts immediately with machine learning engineer models. But if you need also Python, so it's plus 2 months. That's why English course is for 6 months and Russian course is for 8 months. But you can also include learning Python into English machine learning engineer course. Okay, great. And don't forget about internship that goes after the course. Okay, great. So thank you everyone for your questions and for your participating in our second day. By Monday next week, you will have in our Telegram board the recordings of both lessons and yesterday and today's. And I hope see you in our group on February. Thank you, Maxime, for your time. And we will see also Maxime as our mentor in February. Thank you, guys. Have a nice evening. Bye bye, everyone.